Hello all, and welcome to my presentation for the 3R course about, as you may already be able to tell, about bees, or more specifically, why bee populations are declining worldwide. But before we can get into the subject properly, we must establish first what bees are. And this question may be more difficult than it may seem on the surface, because there are over 20,000 different species currently known as Anthophila or bees, and these may range from very different body shapes and colors, like the emerald green one over here, and this one is very interesting, I think. But when you think about bees, you may immediately think about beehives as well and complex bee societies. But most of these species actually live solitary lives on their own and spend most of their days underground or in shallow tree stumps, stuff like that, and not in the typical beehive structure you may think of. But the most, and are all flower feeders, as is evident by this picture as well. They feed on nectar and pollen for their entire diet, for all their nutrients and stuff like that. However, by far the most famous example of a bee is the Apis mellifera, which is this guy, or gal rather, right here, the western honeybee, as it is more commonly known. And when we are talking about the decline of bee populations worldwide, we're most of the time specifically talking about this species. Humans have actually been living with honeybees or bees in general since ancient times in pretty tight um, cooperation, so to say. Initially, just for the prodigies like this cave painting, which is dated to be about 15,000 years old, found in Valencia. You can see a guy right up here harvesting honey, presumably from a beehive, with all sorts of bees around him. And this is a very important example of how bees have always been very intrinsically intertwined with human societies worldwide. In more modern times, bees have been purposely kept by humans. Since the 20th century, about, I believe, humans have been starting to keeping bees for pollination purposes, as bees are pollinators, one of the many types of pollinators. However, in more recent times, something is going quite wrong with bees. Now, what is happening? Managed bee populations worldwide are sharply declining in numbers, and with managed populations, we mean like kept beehives, like imkers, we say in Dutch, beekeepers, people who keep bees for hobby or for selling honey and stuff like that, but also large-scale farmers who keep bees around their facilities to pollinate their crops. This phenomenon of a sharp decline in managed bee populations was first reported in the US, but it's also now spreading to other parts of the world, like Central Europe and Western Europe as well, and Asia, most importantly China. And this graph, I think, is rather shocking, which perfectly illustrates the decline in managed bee populations or honey-producing colonies in the US. As you can see, pretty much from after World War II, there has been a steady decline in bee populations, with notably this event, which we will get into in a bit, which is the introduction of parasitic mites into the US and therefore into their bee populations. Now, this phenomenon is known as colony collapse disorder, which is a rather descriptive name, the collapse of colonies or the decline in number of colonies, which is just an all-encompassing term for the decline in bee populations. Its causes have been largely unknown up until recently, as no proper studies have been done into this subject up until recently. And the data and all the information we will be referencing in this presentation, and which is also most commonly referenced in literature, is regarding managed bee populations, as wild species or data on wild species is very patchy and incomplete. As you can imagine, over 20,000 species that are known, and more species are being discovered every day. So it's rather difficult to monitor such a vast amount of wild insects. Recent studies have found that CCD is caused by a perfect storm of bad influences, first among which are modern farming practices. Now, with modern farming, we mean farming pretty much from World War II up until now. And this is because farming changed rather drastically after World War II. And yeah, this is by far the largest cause of decline in bee populations. And this is largely due to the fact that farming is such an influence in the decline in bee populations, is that there has been a massive increase in need for crops and thusly the production of crops. So farming has become a lot more large scale in recent times. And this is seen in the fact that worldwide, since World War II, there has been a 300% rise in production of crops that need pollination or that are dependent on pollination for procreation, which is rather alarming if you keep in mind that bees, the largest type of pollinator, are declining in numbers. An example of modern farming practice is the rapid increase or the exploded usage of artificial pesticides, fertilizers, herbicides, chemicals, which are used on large scales on modern farms. As this is due to, I have first this graph right here, which is the production and imports of pesticides in the EU, again since World War II, as you can see, rather steep increase. The fact that these chemicals are used so much more since World War II is due to the monocultural character of most modern farms. Most modern farms are vast landscapes of pretty much one or at most two or three different crops. So most farms will specialize, for example, in America, in just corn, or um, or in the Netherlands, we produce lots of different types of lettuce, stuff like that, cabbages. But most farms only specialize in one type of crop. Particularly, we should mind fertilizers, as this has been a large issue in the Netherlands and I believe in other parts of the world as well, which is the nitrogen crisis. Farmers have been using synthetic fertilizers in recent times on a rather large scale due to their more ease of use, and they're relatively inexpensive to use as well compared to natural methods of fertilization, into which we will get to that soon as well, and how that relates to bees specifically. However, an important example of pesticides, and pesticides affect bees specifically more directly, as you may imagine. And one important example of such a pesticide is mentioned in pretty much all the sources I referenced for this presentation. It's mentioned in YouTube videos and TED Talks and all sorts of literature. These are the neonicotinoids, or neonics, as we will refer to them from now on, which is a relatively new class of neurotoxins that's only been introduced since the late 90s, and it's only really being used on a large scale up until the 2010s. It's a class of neurotoxins, more specifically acetylcholine agonists, which overexcitate signaling pathways, therefore causing a death pretty much in insects. But they have proven to be largely safe for consumers and large animals, pretty much those who consume the crops that have been treated with them. However, it's very toxic for bees, as you may imagine, as it is a pesticide. LD50 for a mature honeybee of the most common type of neonic is 4 to 5 nanograms. So that's a pretty small amount, actually, as the amounts found in crops that are treated with this specific type of neonic are about 10 times higher than that. So bees tend to be exposed to lethal doses of neonics pretty easily if they find crops treated with them. LD50 for a larva is also important to mention, as bees that manage to survive treatment with a neonic are of course covered with pollen that are infested with this neonic then and bring it back to their colonies. And the LD50 of a larva of neonics in larvae are about 0.4 nanograms. So that's about 1% of the LD50 in a mature honeybee. So you can imagine it's not very good for them. However, the large effect on colonies is largely unknown in honeybees because they forage such an extremely large area. Because then it's difficult to say for certain how much influence the neonics have on the sustainment of a colony, as they also forage from wild flowers that are not treated with neonics. However, in bumblebees, it has been unambiguously proven that colonies collapse directly as a result of exposure to neonics, as bumblebees forage in a much smaller area. And thusly, studies have been conducted where all the bumblebees from one colony forage from treated with neonic crops, as I say, pretty much all die. So that's pretty sad. To get back to the fertilizer bit, most, as you can see here, most farms have monocultures, which reduces the diversity in diet for bees, but they also don't plant cover crops pretty much anymore. Cover crops have been used as a natural fertilizer, fixing nitrogen in the soil. And most of these cover crops, not this example, I believe these are some types of clovers. Most cover crops are also very healthy for bees, or flower producing plants, stuff like that. So the loss of these cover crops over such vast landscapes, as you can see, this is there it is, the Flevopolder, I believe. So there's our vast landscapes with pretty much no flowers and not very diverse type of flowers that there are, or plants even. So that's pretty sad that bees don't have and even an opportunity to forage. Now, a natural enemy for bees have always been parasites and infections because those occur in nature. However, these are worsened by previous factors, as bees that are exposed to neonics, for example, or even synthetic fertilizers are known to have this effect, or just exhaustion because they have to forage in a much larger area because flowers are so sparse. Bees are much more susceptible to parasites and to viruses. An example of actually the mite that I briefly mentioned in the graph of American bee population is the Varroa destructor, which is this guy, which is a blood-sucking mite, which is I believe originally from Europe, but has been introduced in America due to trade and stuff like that, and has thusly been able to infect populations there as well. Bees are naturally, and they're also susceptible to viruses, of course, as any animal. However, as I mentioned, bees become more weakened due to factors mentioned previously. And this also affects their behavior, as bees are actually able to socially distance because of their complex societies, which we really don't have time to get into today. But however, when they are weakened or exhausted, they of course are not able to do this as effectively. Obviously, they are more susceptible for viruses. Even they do the social distancing thing with viruses as well, but this is just an important example of the mite that I found. They aren't able to do that anymore, socially distance. So entire colonies tend to get infected, and thusly they collapse. Now there's some light at the end of the tunnel. There are opportunities to improve in every field that I just mentioned. For example, the reduction or even the complete ban of synthetic compounds used as fertilizers, or more importantly pesticides, is a very real possibility that's already happening, as both the US and the EU have already pledged to greatly lessen the use of neonics specifically. But also, the EU has been working on for over the past 2 years, I believe, on a complete ban of neonics. specifically for their bad influence on bees. So farmers are then forced to diversify their farmlands. An example of this is the so-called strokenteelt, stuff like this, which has been researched by Wageningen University, wherein farmlands are more diversified, as you see here, with these small stroken, of different crops, which are also harvested at different times, providing different food sources for bees, which I think is a pretty clever idea. And some farms are also resorting to natural fertilizers. It also reduces of course, as I briefly mentioned, the emission of nitrogen, which is of course a hot topic today. And more simply, actually, it's just planting more flowers. You can today buy these seed packs from supermarkets, even which contain flowers that bees like. And even a project like this in Utrecht is this, I believe. This is rather, which essentially plant cover crops all across the city, like on this bus stop right here, which are the same types of plants like alfalfa, as I mentioned previously, clovers, moss, stuff like that, which bees and other pollinators and insects greatly enjoy. And with that, I want to thank you very much for your attention. I hope I was able to shorten down this presentation sufficiently, and let's hope we can plant more pretty flowers like this picture I took in Austria, I believe, last summer. So thank you very much for watching and your attention. These are my references.